loop around. While heat rising from the Sun's core follows these lines toward the surface, the magnetic fields can also stifle them. That's where sunspots form. Where the surface is relatively cool, below, the heat and pressure begin to build. SOHO's detectors have managed to catch the moment when the energy is suddenly released. A shockwave travels rapidly outward, like a solar tsunami. These waves stay on the surface of the Sun as they travel around it. But they are a sign of what's about to happen. They signal the start of a coronal mass ejection, or CME, a massive eruption of particles and hot gas. Using a coronagraph to block out the bright light of the Sun, you can see how violent our star can get. If you see a CME spreading out in all directions from behind this artificial eclipse, you'll know that satellites and power systems on Earth are gonna get hit hard. Especially if that scintillating cloud of bulk plasma is weighted in the direction of where Earth will be in its orbit in about 24 to 36 hours. Whether it's a light solar breeze or a titanic coronal mass ejection, the Sun sends a wave of energetic particles crashing into Earth's magnetic field. When the energy builds to a critical threshold, hordes of charged particles move out along field lines, wrapping around the Earth, and finally flowing in. When these charged particles are channeled and concentrated around Earth's poles, suddenly, with a snap like an electric arc, they'll induce huge jolts of strong current, strong enough to wreck spacecraft and burn power stations on the ground. Or these charges can simply dazzle observers with a silent, awe-inspiring light show. Waves of charged particles sneak through in the far north and south. Creating colorful curtains of light called auroras. The magnificent aurora borealis in the northern hemisphere and the gorgeous aurora australis in the south. But as lovely a light show as this is, it means there are kilovolts of electricity in the air, looking for places to get to ground. And as more and more of the ground around Earth gets carpeted with conductive metal, the chances are that all that juice will fry something vital to humanity. In one important sense, though, the impact of solar outbursts goes beyond electrical and computer systems. Scientists recently found that the Sun's moodiness can change the course of our global climate. When additional solar radiation beats down on the tropical ocean, it raises evaporation rates. With more clouds and rain, the trade winds that circle the equator begin to pick up. You can see the effects in a map of ocean temperatures drawn from satellite data. In the Pacific Ocean, off the coast of South America, brisk offshore winds cause cold water to well up from the deep. This so-called La Niña spreads cool, dry air into North America, while sending a river of cold water racing across the Pacific. The stronger La Niña gets, the stronger will be its counterpart, El Niño. Inevitably, the warm water returns with a vengeance, giving rise to drought and heavy rains in remote parts of the world, while turning portions of the ocean lifeless. Of course, solar outbursts have been affecting Earth's climate for billions of years. But what's different now is that their effects are superimposed on other effects brought on by human-caused global climate change. That increases the challenges that we face in adjusting to our changing world. Fortunately, our ability to monitor and predict the Sun's behavior is getting better. Scientists are, for example, learning to read the wavy surface of the sun, to anticipate sunspots forming on the side we can't see, to detect the presence of these sun storms months before they can affect us. But for those which do escape our notice, the Themis mission was launched to find out how and when the solar wind can threaten us. 4 separate spacecraft are now orbiting the globe, flying wide loops through Earth's magnetic field. What they've found is a turbulent zone, where energy from the solar wind builds. They are looking for the break points when a solar attack becomes inevitable. The Halloween storms of 2003 were a wake-up call. They showed just how vulnerable to solar outbursts our modern society has become. And just since then, many more of us have opted for GPS boxes in our cars. We've run hundreds of miles of new, delicate broadband internet lines into our houses, and we've tucked expensive smartphones in our pockets. Again and again, even in what we thought was the least active phase of the solar cycle, the sun still went from quiescent and calm to downright angry. Yes, solar storm reporting has gotten better, thanks to improvements in our global communications. And yes, we do have more eyes in the sky staring at the sun. But we are still a long way from being able to predict the solar weather. We are in, it seems, a race with the sun. Even as our expanding reliance on technology makes us more vulnerable to solar outbursts, that technology has also now begun to help us evade them.